In this video, let us talk about K-means clustering. First of all, K-means clustering is an unsupervised learning algorithm. Let us see what actually the clustering is. For an example, if we have an axis here and our data got spreaded over this graph. And one more thing, in an unsupervised learning, we don't have the target variable. We only have our input variables. So here we have our data scattered like this. Initially there will be like a single, initially there will be only a single cluster. Okay, initially there will be a single cluster. Now let us take an example of Amazon website. In an Amazon website, we'll have an items of for clothings as a separate cluster. We have electronics as a different cluster, and we have our, maybe can say something, food items has another cluster. So these are all different clusters. This is an example for clustering. Now here I'll just take a simple example. I have a data here which is having an x-axis and a y-axis here, and now I have plotted all these points over here in this graph. Here probably like I can just point it out, 4 4 and 4 7. Now these points are scattered over throughout this graph here. All right. Now what initially it will try to do is it will find out the centroid for these points which are scattered over this graph. Now initially it will be only one centroid. That means whenever we are saying one centroid, that means k is equal to 1. All right. Now when we are saying k is equal to 3, that means it's going to have three clusters. That means it's going to find out three centroids, and here we have only one centroid, which is also called as one cluster here. Now here in this case, when we are saying that k is equal to 3, that means it's going to have three clusters. Now randomly I'm just trying to find out the points over here. Randomly I'm just selecting here. Let's say this is our C1, and this is our C2, and this is our C3. Now C1, I'm randomly selecting a point in the graph which is having 1 comma 5, whereas C2 is having 4 comma 1, whereas C3 is having something around 8 comma 4. All right, so these are all my data points I've just selected randomly. I'm also selecting the k value randomly as k is equal to 3. I would like to find out the decimal points, all these points. Now similarly, I'm also trying to do the same thing with respect to C2. This time I'll just try to find all these points, and I'll try to find the distances between all these points. Now here, to calculate the distance, I'm going to use Euclidean distance. Euclidean distance is something like when we have 2 points over here, when I just draw a line, I can just simply calculate by square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is my Euclidean distance. So we are using this Euclidean distance to find the distance between from the C2 and to the rest of the points. Similarly from C1 to the rest of the points. Similarly for C3 to the rest of the points. Now finally we get our uh, our points C1, C2 and C3 selects the points which are actually nearer to the points. Like whatever the point nearer to C1, it will be selecting, and it will be considered as a cluster C1. Whatever the points which are near to C2, that will be considered as cluster C2. Similarly, whatever the points that are near to C3, that will be considered as cluster C3. Now let us look at an example here. Now what we are doing here, initially we have picked up randomly 3 points and saying that those are the 3 initial centroids. which is C 1 comma 5 and 4 comma 1 and then 8 comma 4. Now from here I'm just trying to use here, uh, I'm just trying to plot this. Okay, C1, C2 and C3 here. I have just made it as a columns. Now I would like to find the distances between this C1 to this X1, Y1. Okay, now to find the distance, I can just simply use a formula here, which is my 1 minus 2 whole square plus 5 minus 4 whole square. So we have got a value called 1.41. Similarly, for the next point, we are going to calculate in a similar way, which will be 1 minus 2 whole square plus 5 minus 6 whole square. And similarly, we are going to calculate for the rest of the points for the centroid C1. Similarly for C2 and similarly for C3 as well. Now here we are trying to figure it out the cluster. How do we find out which cluster it is going to be? Now whatever the minimum distance that is calculated out of these three centroids, so minimum we have here 1.41, which is coming under C1. So our output here will be C1. So this point is near to C1 actually. Now it will be considered as in the group cluster C1. Similarly, we are trying to find the same thing for each row. Here in this case again C1 is the minimum. So here our outcome is C1. Again here we have C3 is near for C3 is near here actually. So now we are considering the outcome as C3 and here again C1. So now we'll have all these points, whatever that comes minimum, we are trying to put up here in the cluster number. Now this time we are trying to find the centroids. Now C1 has, now all this C1, all this, suppose this is for C1, okay, this is for C1. We are now trying to find out the centroids. Now this is the C1, okay, now this is the C1. Now for all, because these are categorized into C1 cluster. Now for all these points we are trying to find the centroid. In this case centroid will be for centroid C1. Our new centroid C1 will be 2 plus 2 plus 4 by 3. This is for x-axis, and 4 plus 6 plus 7 divides by 3. This is for our y-axis. Now we'll get a value of 2.67 and 5.67 when we calculate this. Similarly, for rest of the centroids, we are trying to calculate the rest of the cluster. We are trying to find out the centroids. Okay. Now we are going to have these values. Now what we are trying to do is we are trying to update all these values. We are trying to update all these values to here. This will be our new centroids now. This will be our new centroids. Now again, with these new centroids, we are trying to find the distances from this xy and to this centroid C1, centroid C2, centroid C3, and the same kind of calculation we are trying to make it here. Now here in this case, we are also doing the same kind of methodology. We are going to select whatever that comes minimum here. So here again, C1 is minimum. So one thing we can observe here, there is a change here, that this C3 cluster is getting transferred into C2 cluster here in this case. Now the point is just the points are shuffling now here. So see now here when we have did our second iteration, we are trying to find uh, the point. This point is near to our cluster C2. Now it will take into the cluster C2. So this movement we are going to have in this iteration. Now further again we are going to have another iteration again. We are again here we are trying to find out the centroids again, because we have the change in the clusters, so there will be a change in C2 centroid and C3 centroid. We are going to update these values. Now these new centroids will again get into this new table, and again we'll have our new centroids here. With the help of new centroids, we are trying to find the distances, whatever that comes minimum. We are trying to identify those clusters. Now here in this case, we are again trying to find out the centroids. Okay, now here in this case, we have got a change from earlier this is C3, now just became C2. Now our C2 and C3 centroids are going to update here in the iteration 3. Now again these new centroids will form a new table again. So this method will keep on continuing until there won't be any change in the cluster. So in the iteration 4 also we observe the change here. This has changed here again. Now in our iteration 5 there are no changes. From iteration 4 to iteration 5 we don't find any kind of changes. So finally this will be our output. Now you can see it here. Our final clusters are, you can see 2 4 2 6 will be coming into the category, into the cluster 1. Again 5 6 5 6 4 7 4 7 and 6 6 6 6 and 5 7 are sorry uh, yeah, then 5 7 are going to come into the cluster 3, and the remaining will fall under cluster 2. So this is actually the methodology to select the clusters actually. So this is so it will take some iterations to get our output. It won't just directly get initially. Now let us understand what is an elbow method. What is an elbow method? Now here an elbow method is, we need to find the optimum value of k. Suppose let us use k is equal to 1 to 20. Okay, suppose we k is equal to 1 to 20 means it's starting from one cluster till 20 clusters. Suppose if I have a data set in this graph here like this, which got scattered over here like this. All right. Okay. Now here I have initially I have one centroid. Randomly I'm just picking it up. Suppose if I have one centroid here. Now here there is a formula called WCSS within cluster sum of squares, which is given by a formula called I is equal to summation of I is equal to 1 to n Ci, the centroid value, plus the data points, the input points, whole square. So this is our within cluster sum of squares formula. Now when my k is equal to 1 here, suppose uh, if I have a k is equal to 1, then my WCSS value is also going to be very high. Now here you can see that if you would like to find all the distances between these points, and we are going to add with SCI centroid, right? So obviously my WCSS is going to be very high. Suppose if I have another point here, some points will go to this centroid C1, some points will go to some centroid C2, then my WCSS will have a lower value. So when we are increasing the k value, there will be a decrease in WCSS. So where let me just show it in the graph. It will be a better visual experience. Now here I'm just trying to graph over. Let's take our WCSS in the y-axis. Okay, and let us take our k value in the x-axis. Now here when my k value is equal to 1, my WCSS is quite high. Now when my k is equal to 2, now it's going to bring up a little bit down. When k is equal to 3, it's going to be a little bit more down, and 4 it's going to be, and after some point it's not going to have a major change. So it'll be like this. Why we are calling it as an elbow? Because it's in the shape of elbow. Now you can see here, I mean it's not coming to the graph, but when you see here, suppose you can see there is an abrupt change in when k is equal to 3. So now here our k is equal to 3 is our optimum method. So this is the optimal value for k means clustering. So this is how we select actual k value. So where we find this will be our optimal value, and this will give a better results. All right, this is it in this video. I'll talk more in our next upcoming videos. Thank you for watching.